Hi there. This video is about a second type of looping structures, while loops. A while loop repeats a set of commands as long as some condition is met or is true. If the condition becomes false, execution of the loop stops. This can be convenient in many cases. You can set up a while loop to perform a set of calculations a specified number of times, just as you could use a for loop to perform calculations until some conditions met. So anything you can do with a for loop, you could also do with a while loop, and vice versa. However, knowing which structure is most convenient in any given application can save you work. This is the general syntax of a while loop. The loop starts with the word while and ends with the word end. The while statement includes an expression which evaluates to either a logical true or a logical false. Between the while and the end statements is a set of code that gets executed repeatedly. When the code's executed, the commands inside the loop are evaluated repeatedly as long as this expression remains true. When this expression becomes false, the loop terminates and execution picks up with the next command after the end statement. Now, if the expression isn't true when the while statement is encountered for the first time, the block is just skipped and these commands never get executed. On the other hand, if the expression never becomes false, the loop never ends. That means that something inside this loop must happen to change this expression. Before I do some examples, there's a few notes I want to make about while loops. First, unlike for loops, you generally don't know ahead of time how many times the loop's going to execute. In fact, it's possible for a while loop to never end. If the expression in the while statement never becomes false, the loop has no way to terminate. You can terminate execution of MATLAB commands manually. To do this, just hold down the control key on your keyboard and press C. This tells MATLAB to stop whatever it's doing right now and return control to the command prompt. I'll demonstrate this briefly before going on to some examples that illustrate a correctly functioning while loop. I've created a script file named infinite loop in the current folder. It's shown here. A value gets set for variables named x and number. The while loop will execute as long as x is greater than 0. X is 2, so the first time through the while loop starts. However, the only thing that gets done within the loop is that the variable number is incremented by 1. So x doesn't change. It's always 2, so it's always greater than 0, and the loop never ends. Now I'll run the code to see what happens. MATLAB just goes away and never comes back. It's very happily running this file and won't do anything else until it's done. I can terminate execution and get MATLAB's attention back by holding down the control key and pressing the C key. The command prompt comes back and control of MATLAB is returned to me. Just for fun, I'll see how high MATLAB counted to by typing number and pressing enter. In this example, I want to determine the final value of sum resulting from this given code. First, k is initialized as 1 and sum as 0. And x is initialized as an array. Next, the looping structure is encountered. As with for loops, I'm going to fill out a table as the loop is executed to help me keep track of what's going on. The logical expression in the while statement checks whether x of k is greater than or equal to 0. When the loop is entered for the first time, k is equal to 1, so x of k is the first element in this array, and it's 1. 1 is greater than or equal to 0, so I get to go into the loop. Sum starts out as 0, so sum is 0 plus 1, which becomes 1. Next, I add 1 to k and assign that to k. 1 plus 1 is 2. I hit the end statement, go back up to the while loop, and check to see whether this condition is true. X of 2 is equal to 5, which is greater than or equal to 0. So sum is equal to 1 plus 5, or 6. K is incremented to 3. 2 plus 1 is 3. The end statement's encountered. I go back up here. X of 3 is 0. 0 is greater than or equal to 0. and I enter the while loop. 6 plus 0 is 6. K is set equal to k plus 1. The end statement is encountered. I go up here, evaluate this expression. So x of 4 is equal to -9. This is now false, and I stop executing my while loop. I go down and pick up and do anything after the end statement. So when all is said and done, sum is 6. The next example is to count the number of positive values in an array that's terminated with a 0. That means that the last element in the array should be a 0 and no other element in the array is a 0. I start out by initializing an array named x to these values. I need to calculate the number of positive values in the array. Notice that the last element in the array is 0. This gives me a condition I can use to terminate the while loop. I'll also initialize values for variables named POS, which will be used to count the number of positive values we find, and n, which will be used as a counter to work my way through the elements of x. I'm going to use a while loop, and my condition for terminating the while loop will be when the value of x is equal to 0. So this condition will keep the loop executing as long as this is true or as long as x of k is not equal to 0. The first time through the loop, n is equal to 1, and x of 1 is equal to 4. Now when I enter the while loop, I check to see whether 4 is not equal to 0. That's true, so I enter the loop and check this. Is x of n greater than 0? 4 is greater than 0, so I add 0, my original value of POS, plus 1, and I found one positive element in my array so far. Then I get to this end statement. The decision making is done. I increment n, 1 plus 1 is equal to 2, get to the end statement that's associated with the while loop. X of 2 is 2. 2 is not equal to 0, so I go in here. 2 is also greater than 0, so I add 1 to POS, and I found 2 positive elements so far. That finishes my decision. N is equal to n plus 1. Going back up to the while statement, x of 3 is equal to -3. -3 is not equal to 0, so I go in here. -3 is also not greater than 0, so I skip doing this, and POS retains its value. Now I add 1 to n. X of 4, 1, 2, 3, 4, is equal to 6. 6 is greater than 0, so I add 1 to POS. I add 1 to n for the next time through the loop. 4 plus 1 is 5. Go back up here. X of 5 is equal to -1. -1 is not equal to 0, so I go in here. -1 is also not greater than 0, so I don't change POS. N is equal to n plus 1. When n is equal to 6, x of 6 is equal to 0. This is no longer true, and I've finished execution of my code. Sum is equal to 3. I've found 3 positive elements in my array. Finally, I'll use an infinite series to estimate the value of e to the x. This is the mathematical expression I'm going to use. It's a summation from k equals 0 to infinity, counting by ones, of this expression x to the k over k factorial. So the first element here, when k is equal to 0, becomes x to the 0 over 0 factorial, which is just 1. The next term will be for k equals 1. So this becomes x to the first over 1 factorial, which is just x. The next term for k equals 2 becomes x to the 2th over 2 factorial, which is x squared over 2, and so on and so forth. Now, I'm going to keep calculating terms until the next term is less than 1 times 10 to the minus 6th. So as usual, I'll start by writing a little pseudocode. I need to initialize values for x, expx, and tolerance. Tolerance is this 1 times 10 to the minus 6 value. I'll initialize expx to 0, so this sequence will become 0 plus 1 plus so on and so forth. The looping structure I'm going to use will be a while loop, which requires a condition. In this case, that condition will be fulfilled when the next term is less than 1 times 10 to the minus 6th. I'm going to use the variable named delta as the value of the next element in the series. Now, in order to enter this loop, I need to initialize a value for delta with a value that's bigger than 1 times 10 to the minus 6th. If I initialize delta to 1, I've taken care of this term here for k equals 0. So the first value of k that I need to use inside the loop is going to be k equals 1. Now in my loop, EXPX is initially 0 and delta is equal to 1. Delta is greater than 1 times 10 to the minus 6, so this condition's true, and I can do the first set of calculations in the loop. The first thing I need to do is add delta to EXPX so that now EXPX is 1. Now I calculate a new value for delta and then increase k by 1 for the next time through the loop. This brings me to the end of the loop, so when the loop goes back to the while statement and checks to see if delta is greater than the desired tolerance. If it is, the process repeats. This continues until delta becomes small enough the expression in the while loop is false and the loop terminates. There's a variety of different ways to get to the same result. For example, I could initialize k to 0 and then update k and recalculate delta before I calculate a new term. Now I'll implement the code in MATLAB and flesh out the details. First, I'll create a file named myexp.m in the Chapter 10 folder. Before I do anything else, I'll initialize the constants. I'm going to name the variable that contains my estimate of the exponential function expx. So I'll initialize expx to 0. I'm calling the next term in the series delta, and I'll initialize delta to 1. I'm using k to count the next term in the series. Since my initial value for delta corresponds to k equals 0, the next term will be for k equals 1. At first, while I'm testing the code, I don't want to calculate very many values, so I'll initialize the tolerance, TOL, to 0.5. Last but not least, I need to choose a value for x. I'll set x equal to 2. Now I'll create the looping structure. Since I'm going to use a while loop, the first statement is, of course, the while statement. I want to continue to loop until the next term in the series is less than the tolerance. So the while statement becomes while delta is greater than TOL. Now the way I've initialized my parameters, the first thing I need to do inside my loop is to add delta to EXPX. The rest of the commands in the loop consist of setting parameters to be used during the next loop. First, I'll calculate the next value for delta. So delta equals x to the k divided by factorial of k. MATLAB's factorial function returns the factorial of its argument. The last thing I need to do is increment k so that it can be used the next time through the loop to calculate my next delta. So k equals k plus 1. Finally, an end statement terminates the loop. Notice that I haven't followed my statements with semicolons. While I'm testing the code, I want to see the values that are being calculated. That's one reason I use such a high value of tolerance to test the code with. I only want to see a few values for now to make sure that the loop is progressing as I want it to. Now I'll save the code and run it from the command window. However, for the purposes of this video, I don't want a lot of white space on the screen, so I'm going to change the display to compact by typing format compact at the command prompt. Now I run the file by typing myexp at the command prompt and pressing enter. The first time through the loop, delta is 1 and expx is the initial value of exp, which is 0, plus 1, which is 1. The next time through the loop, delta is 2, which is just x, and expx is 1 plus 2, which is 3. The next time through the loop, delta is x squared divided by 2 factorial, which is 4 divided by 2, which is 2 again, and expx is 3 plus 2, which is 5. Now that the code seems to be working, I'll reduce the tolerance to my original desired value of 1 times 10 to the negative 6. Since this will require a lot of terms to be calculated, I'm not going to want to watch these values scroll by, so I'll add semicolons to my executable statements. I'll save the file, and run it from the command window. To see my calculated value of exp of 2, I'll type the variable name. So expx. It's 7.3891. I can check this number with MATLAB's built-in exp function. So exp of 2 returns the same thing. It looks like my function agrees with the expected value. This completes the presentation of looping structures. In summary, there are two possible approaches: for loops and while loops. It probably doesn't really matter which one you use for any given problem. Pretty much anything you can do with a for loop, you can also do with a while loop. That doesn't mean that you shouldn't learn both approaches. If you're proficient in both, you can be more flexible in your problem-solving approaches. However, many looping type of operations are generally more efficiently performed using MATLAB's built-in functions and array operations. In the next video, I'll give you some tips about these operations.